So first here we're going to graph these points, and then we're going to determine if the ordered pairs given are in fact linear. So when I plot the points 1, 5, it goes right there, and then 2, 7, 3, 9, 4, 11. I know it goes off here, but just a little bit. 5, and then 13. So I know it went off a little bit, but if you paid attention to you putting these dots in, you see that each time you go from one dot to the next, you went up 2 and then to the right 1. That's a slope of 2. And all of these are in a line, and every time you go up 2 to the right 1, up 2 to the right 1. That means, when you connect all of these, that this is in fact linear. Now let's look here. I get the point 0, 0, 1, 1, 2, 4, 3, and then 9. And as you connect these, you see that it curves. So this would be nonlinear. The one before it is linear. This one is now nonlinear because the line curves, so it does not have a constant rate of change. This one is linear because it has a constant rate of change, or a slope, or it rises at the same rate. So let's plot these points. 1, negative 1 is there. Then 2, 2, 3, 5, 4, 8. And as you noticed, these look like they're in a line, so if you could connect them, but you'll see that you go up 3 to the right 1, up 3 to the right 1, making my slope triangles here, and all of my slope triangles are the same, so this is linear because it rises at a constant rate of change, which my rate of change in this case would be 3. Does each relation represent a linear function? And we need to explain. So here I'm going up 2, then I'm going up 3, then I go up 1, then I go up 2. These are all going up at different rates, which is okay depending on what happens with our output. So here I'm going up 1, up 1, up 1, up 1. So these are going up the same. Since these are the same and these are different, okay, they're not doing the same thing, therefore this is nonlinear because there is no constant rate of change. It is not rising at a constant rate or falling at a constant rate. So therefore I cannot find the slope, therefore it is nonlinear. Here, plus 1, plus 2, plus 3, plus 4. Again, this is okay depending on what happens. It's okay for these to be doing different things depending on what happens here. Plus 3, plus 3, plus 3, plus 3. These are the same. Since this side, my inputs are the same, my outputs are different, this is also non-linear because it does not have a constant rate of change. So let's check our outputs here. We're going down 3, down 3, down 3, down 3. Here's the same, so that's good. Okay, but the other side has to be the same then as well. This goes up 5, up 5, up 5, up 5. So this is linear because there is a constant rate of change of -3/5. So it is decreasing at a constant rate of -3/5. So what is the rate of change of this function? So it has a rate of change. We're saying it is linear. So let's find the rate of change. Same thing, each one. Here's plus 4.4. Then I add 4.4 again. Then I add 4.4 again. My x values or my input values, adding 10, adding 10, adding 10 each time. So the rate of change of my function is 4.4 divided by 10, which equals 0.44. That represents the amount of water pressure per foot. So water pressure per foot that the diver dives. So let's use the rate of change to predict the water pressure at a depth of 60 feet. Okay, I see feet is my y value, and 100 feet. So I'm going to be solving for y here. But first I need to come up with my equation. So I have y equals my m, I've already identified as 0.44, x, and then it's plus b. But if you think about it, b is when x is 0, or my water depth is 0. If I'm at 0 feet, how much water pressure is there? There isn't any. So this is a proportional relationship because my y-intercept would be 0 in this case. So here's my equation. So first I want to find 60 feet. So I substitute 60 in for x, and I do 0.44 times 60, and I get my y value to be 26.4 pounds per square inch. And now for the 100, 0.44 times 100. 0.44 times 100 is 44. So at 100 feet, there will be 44 pounds per square inch of water pressure. So what is the rate of change and what does the function represent here? So again, we have to find, we're told it's linear, so there is definitely a constant rate of change. So if I take 44.5 and subtract 40.75, I get 3.75. And if I do the same for all of these, 48.25 minus 44.5, and then 52 minus 48.25, I get 3.75 each time. Here, plus 5, plus 5, plus 5. So my rate of change of this function is 3.75 divided by 5. And that equals 0.75. Now that represents the length that this animal grows. And it grows because it's a positive rate of change per year. So now we need to predict at 25 years. Years is my x value here. And at 40 years, again, years is my x. So we're given x equals 25 and x equals 40. But I need to solve for my equation. I already know my m. So y equals 0.75x plus b. Now I need to find what is my y-intercept. What's my b? When my x value is 0, what is my b? Well, since I'm going by 5s over here, if I go up by 5 and I subtract 5 to this top one, I get to 0. which means I need to subtract 3.75 from 40.75, and that gives me my y-intercept. So my y-intercept in this case is 37. So now what I need to do is substitute 25 in for x, and I'm going to do 0.75 times 25, and that gives me 18.75 plus 37, and then add 37 to get 55.75 centimeters. So in 25 years, this animal will be 55.75 centimeters long. Now in 40 years, I substitute 40 in for x, just like I did with the 25. And now I begin to solve. So 0.75 times 40 is 30. 30 plus 37 is 67. So in 40 years, this animal will be 67 centimeters long.